Hello again, welcome back. This video again is a continuation of that strategy decision problem example we have been looking at. If you have not watched the initial video in which I described the story of the problem and we build the decision trees for it for parts A and B, please do so first because otherwise this one is not going to make sense. In this video here, we're going to look at the concepts of value of sample information and value of perfect information. If you want to go and watch the initial video first, I'm going to leave a link to that in the description of this video and also a link here that you can click. It's going to pop up at the top in a second. Great. So what is value of information? It's basically how much is going after additional information, how much that brings to you in terms of improvement in your expected monetary value. So if you recall from the story of this strategy problem, we could go with the information we have now, that is, we just make a choice of strategies: aggressive, basic, and cautious. And that is going to be based off of our payoff table and our initial belief of strong versus weak market. And according to the decision tree, if this is how we want to proceed, the best thing to do is to do strategy B. And our expected monetary value, which I'm going to be referring to as EMV from now on, is 12.85%. So this is the EMV with no extra information, right? EMV with no additional information. I like to call this guy the base case EMV. Okay, as in, if I don't ask for any extra help, what can I do with what I know now, right? And what I can do is 12.85. Now, these people were given the choice of performing a test, which costs money, but ended up improving their EMV, even though you had to pay for it. So this thing called the EVSI, and that acronym stands for Expected Value of Sample Information. It's called sample information because you can think of it as it's taking a sample of the world, right? If you're performing a survey, you're sampling a few people and then listening to them. So what is the value of sampling the world of some information, right? That's the EVSI. Well, the EVSI is of this test, right? Is what? If I didn't have to pay for the test, how much better would the test make my expected monetary value? How much better than what? How much better than my base case? How much better than what I could do if I didn't ask for the test's help? Well, we know that this number here, 12,955, is the EMV of doing the test after we pay for the test. But the definition of EVSI is if you had a free test, right, how much better do you get? Well, to calculate this, it's simple. You take, get this number here, which is discounting the cost of the test. So I'm going to add back that expense because I'm going to assume the test was free. And this is the overall improvement the test gives me. And I subtract from this number my base case, meaning what could I do by myself without the test's help. And this difference will give me the improvement caused by the test, had the test been free. So what is it saying? $605,000, because these numbers are in millions, is the value of this test. You can interpret this number as what is the maximum you would ever pay for this particular test? $605,000. That's why even though it cost $500,000, I still chose to do it because it brings in a value of $605,000, more than $500,000. So as long as this test costs you, this specific test with this power of prediction that it has, it makes mistakes as we saw in the other video. This particular test with its power of prediction is worth to you, in expectation, $605,000. So this is called the EVSI, the expected value of free sample information. All right, how much better the test makes you, from your base case if the test were free. Great. The next important concept is the EVPI, right? And the P stands for perfect, expected value of perfect information. If I had a perfect test, well, that doesn't exist, but we can still calculate this number and compare it against the EVSI to get an idea of, how good could a test ever be? Is this test approaching the level of a perfect test? Is it far away from, right? So how do you calculate EVPI? Well, it's also going to be a difference between if I had a perfect test minus what can I do by myself, right? Like I did before. Now you can think of a perfect test as a crystal ball, right? If you had a crystal ball that you could ask, will the market be strong for my product or weak? Well, look at this particular payoff table, right? Up here. If you knew ahead of time that the market is going to be strong, what would you do? Well, you just choose A, right? Because A is the one that gives you the highest value in the strong column. And if you knew ahead of time, if you had a crystal ball that would tell you the market will be weak, you would go with C, because C gives you the highest payoff in the weak column. Now, the market is not strong or weak all the time. It depends. Sometimes it's strong, sometimes it's weak. And it's strong versus weak with these chances. So if you were to have a crystal ball and ask it, will the market be strong? There's a 45% chance the crystal ball will say yes. In which case, you would do A and make 30 million. And there is a 55% chance the crystal ball will say no, it's going to be weak. In which case, you would go with C and make 15 million. So if you had a crystal ball, there is a 45% chance you would make 30 million because you would choose A when the crystal ball says strong. And there is a 55% chance you would make 15 because the crystal ball would say weak and you would choose C. So this is how well you would do if you had the ball. And if I take from this number what I could do without the crystal ball, just on my own, the base case performance, right? Then I get 8.9 million. Okay, so and this is the value of having a crystal ball that costs you no money. How much better does it make me? It makes me better by $8.9 million. So as you can see here, this imperfect test makes you better by $605,000, and a fictitious perfect test would make you better by almost 9 million. These numbers are really far away from each other. This could be some indication that this test you are using is not that great. I'm not claiming that it's possible to do better, but it looks like there's a lot of room for improvement here, right? So this number is not attainable, but it might be used as some point of reference to compare against what is attainable. In this case, maybe it might be worth, asking around, maybe look at other consultants that do these kinds of surveys, and maybe their tests are a little more accurate. Okay, but that's the idea of EVSI and EVPI, and that's what I wanted to cover in this video. Again, remember that the value of information has to consider the information as being free, so don't forget to discount the cost of the test. And these are always relative to what you could do if you had the help versus when you don't have the help, and that's your base case EMV that you can get by yourself. All right, Great. Thank you for watching. I hope this was helpful, and I'll see you guys for the next video. Bye-bye.